Yeah, yeah. Okay. Tonight we'll be looking at integration. I'm going to teach you how to integrate a given function. But before that, let's look at the basic functions that integration is talking about. These ones, you are supposed to know them here, put them here. So anything I'm going to write down, put it here. Is that clear? So that when, by the time we apply it, you will recall it fast to make use of it. Is that clear? It's okay. So here we have 1. If we integrate as raised to power n dx, this will give us as raised to power n plus 1 all over n plus 1 plus any constant. And this is the formula for integration. Then 2, we'll be looking at if you are asked to integrate cos ax dx, you are going to have 1 all over a sine ax plus any constant. Is that clear? Are you following? Is that clear? Okay, so let's proceed. So likewise, these ones you need to put them here on your head. Likewise, if you integrate sine ax dx, you're supposed to have minus 1 all over a cos ax plus any constant. Not necessarily k, could be b or 4. If you integrate 1 all over x dx, that is, this is the same thing as this implies integral dx all over x. It's the same thing as this. So whenever you integrate this, you are going to have in x plus any constant. Take note. Are you following? Do you understand? Do you understand? And whenever you integrate sine square ax dx, you are going to have 1 all over a tan ax plus k, because when you differentiate this, you are going to get back this, two of us. Because if you differentiate tan x, you are supposed to have sec square x, two of us. So the same thing. Then cosec square ax 6, if we are to integrate cosec square ax dx, we are going to have minus 1 all over a cot ax plus any constant. Is that clear? Cosec square. Yeah. So when you integrate 7 integral exponential ax dx, you are supposed to have what? Exponential ax all over what? A plus the constant. Is that clear? Do you understand? Do you understand? These things you are supposed to put them of hand. So please try and invite others who are still sleeping. Is that clear? So far, so good. So let's go ahead to integrate some functions. Are you following? Let us go ahead to integrate some functions. is simple as ABC. It's okay. It is okay. Yeah. Let's go ahead to integrate some functions. Yeah. Determine example. Let's consider example. Example, determine integral 5x dx. So what we need to do, let's first write solution, right? Solution, integral 5x dx. This is equals to, mind you, there is an invisible one, and this integral we can still rewrite it in this form. 5 is a constant, so we can write 5 outside. 5 integral x dx. So if we are to integrate this x, we are going to have 5 times x raised to the power of 1 plus 1 all over 1 plus 1 plus any constant, either b. True or false? Then this is equals to 5x squared all over 2 plus the constant. So this is how to integrate any given function. Do you have any question? Please drop it in the comment section. Drop your question in the comment section. Any question? Oh, somebody is asking me to start again. Banamina. Amina. Okay. No, what I'm trying to say is it means you don't understand the definition of integration. You know, integration means when you have a function ax raised to the power of n, we can still rewrite this function this way because this a is a constant. Then we write it in this form. Amen. So if we are to integrate this, we are going to have ax raised to the power of what we have here, n plus 1 divided by n plus 1 plus any constant. It could be c, any constant, either a, b, c, k, h, any, but it must be capital letter. So this is the formula for what? Integration. So whenever you are integrating any given function, you have to put this formula in your head. So now, look at it now. We have a function. They said we should integrate 5x dx. So our integral 5x dx equals to 5 integral, that is, we can rewrite this integral in this form, x dx, which is equals to, we have invisible one here, true or false, which is your n. So 5x raised to the power of 1 plus 1 all over 1 plus 1. Then plus the constant. Then 1 plus 1 is 2. All over 1 plus 1, 2. So 5x squared all over 2 plus k. Do you understand, Amina? Are you following? Do you understand? Yes or no, Amina? Can we proceed? Is there any question? Yes or no? Can we proceed, please? We can proceed, right? Okay, let's proceed. If that is the case, let us proceed. Please try and invite others. The class is so scanty. Like and share. It's okay. So let's go ahead to consider more examples here. Okay. Okay. Let's integrate this. So determine integral of 2t raised to the power of 3 dt. So what should be the answer? Please look at the board. You don't need a prophet to tell you. I want somebody to tell us this answer. Write it in the comment section. Please, before we begin to solve this, write this answer in the comment section. I give you 2 minutes. 2 minutes. Who is there? Who is there? I give you 2 minutes to do that. Write it in the comment section. 2 minutes. Who has solved it? Salamatu Tazudun. Solve it. Mohammed Tijani. Solve it. Ahmed. Who has finished it? Nobody? Please, I'm waiting. 1 minute more. Write it in the comment section. You are just coming, Manuel. You are telling me through more light. You are just coming. You understand, don't worry, just be with us. Okay? Yeah, 2t raised to power 4 plus 2. Kenneth Peter, well, you did not write the constant plus constant now. You got it. You got it, but you forgot to write the constant. Powers of 4 divides 4. Kenneth, you did not get it. You got it wrong. Sorry. Here is 2t raised to the power of 3 dt, right? So we can still rewrite this in this form, t raised to the power of 3 dt. Then this is going to give us what? 2t raised to the power of 3 plus 1 all over 3 plus 1 plus any constant k. Then this is equals to 2t raised to the power of 3 plus 1, 4 all over 4 plus the constant. But 2 can divide this side 1, 2 to 4, 2. So this is the same thing as t raised to the power of 4 all over t plus any constant. Any doubting, Thomas? Please look at the board. Are you following? Are you following? So can we continue? Why are you still having 4 dt? Salmatu, you got it wrong. It's okay. So let's proceed to consider more examples. Okay. They said determine integral open bracket 4 minus 3x all over 7 minus 6x squared all in bracket dx. Is that clear? So these are what? Quadratic functions, because the highest power here is 2, right? So what you need to do after writing solution, integral open bracket minus 3x all over 7 minus 6x squared dx. We can still rewrite this integral in this form. Integral 4 dx. What do you have here? Minus, right? Minus integral 3x all over 7 dx minus integral 6x squared dx. It means this is the same thing as this. Take note. Is that clear? So if you agree with me, let's differentiate this. We can rewrite this in this form. We have 4 here as constant. 4, factor it out, dx minus, you have 3 all over 7 as constant, as a constant. Then we have x dx. Then we have 6 as a constant, 6 integral x squared dx, right? Okay. So this is equals to, if you differentiate the x, you are supposed to have x, true or false. So use it to multiply this function. Here will be x, then minus differentiate x. I'm supposed to have x raised to the powers of 2 all over 2, right? Then multiply 3 all over 7, so 3 all over 7 times x raised to the powers of 1 plus 1 all over 1 plus 1, right? Then minus, if you differentiate x squared, you are going to have x raised to the power 2 plus 1 all over 2 plus 1 times 6. So 6 times x raised to the powers of 2 plus 1 all over 2 plus 1 plus any constants, either a. Do you understand up to this point? Please ask your question if you don't understand. If you don't understand, ask your question. Any question so far? Any question, please? Any question, yes or no? Any question? Where did I get 4x? Are you not seeing the constant there? 4 integral dx. You are just coming. Mohammed, you are just coming. Amina, you want me to explain again? Where were you? This 4 is a constant now, 4 dx. So we can factor this out. Then 3 all over 7 too is a constant. We can factor it out, x dx. 6 too is a constant. We can factor it out of the integral. So it means this we can rewrite it this way, and this we can still rewrite this in this form. So we are just to consider if you integrate dx, you are supposed to have x. So when you have x, what do we have here? 4. So you use 4 to multiply, is it not 4x? Then if we integrate x dx, you are going to have x raised to the power of 1 plus 1. Look at it here. All over 1 plus 1 times this constant, 3 all over 7, minus, if you integrate x squared dx, you are supposed to have x squared plus 1 all over 2 plus 1, that is x raised to the power 2 plus 1 all over 2 plus 1 times the constant plus any constant a, b, c, d, or anyone. Do you understand, Amina? Are you following? Are you following? Amina, gospel, with what I have explained, you should be able to understand. It's okay. So let's proceed further. So here we are going to have 4x minus 3x squared, right? All over 7 times 2 plus 1 plus 1, 2, right? Times 7. Then minus 6x raised to power 4, raised to power 3 all over 3 plus a. Is that clear? So this is equals to 4x minus 3x squared, 7 times 2, 14, right? Minus 3 to 8 7, 3 to 6, 2. 2x cubed plus a. This is the final answer. Any question, please? Do you have any question? Any question? Do you have any question? Yes or no? Or we should continue? Hope we are right. Are we right or wrong? We should continue, right? We should continue, right? Should we continue, yes or no? I want to clean and let us start. C square, where is C square? There is no C square now. Here, 3 divided itself 1. 3 to 6 is 2, not square. You see the cancellation now? It is not square. 3 to itself 1. Then 3 to 6, 2. There is nothing like C square. Please take note. Okay. Let's proceed further to consider more examples. Is that clear? More examples. Okay. Evaluate integral of 2x cubed minus 3x all over 4 dx. It's simple as ABC, but before we begin to evaluate this integral, I want us to know something. If we have a plus b all over 4, this is the same as a all over 4 plus b all over what? 4, right? Okay. So assuming we have a plus b all over 4 dx. So we are supposed to have a dx all over 4 then plus b dx all over 4. This is how it's supposed to be. Take note because we are going to somewhere. Is that clear? So far, so good. So you can see what I'm saying. Sorry. Here is 4x. So this implies that integral 2 raised to the power 3 minus 3x all over 4x dx is the same thing as integral 2x raised to the power 3 all over 4x minus 3x all over 4x dx. Then we can still rewrite this integral in this form. Integral 2x raised to the power 3 all over 4x dx minus integral 3x all over 4x dx. True or false? Right? Then this is the same thing as let's cancel this x to this, then 2 to itself 1, 2 to 4, 2. So the integral will now be x squared all over 2 dx minus here x to x. True or false? Integral will now be 3 all over 4 dx. True or false? It's true. Then this is the same thing as here, when we have x squared all over 2, this is the same thing as 1 all over 2 times x raised to power 2. True or false? So we can factor 1 all over 2 outside is a constant, then x squared dx minus factor 3 all over 4 out, a constant dx, right? So this is equals to 1 all over 2, integrate this, you are second line. Some of you are just coming, so you won't understand. After the class, go back to the video. Take your time and study it very well. Be able to understand what I'm teaching you. You are just coming, that is just the problem. Is that clear? Okay. Let's proceed. Let's proceed to consider more examples. We have another example here. We have another example here. It said integrate. Some of you are just coming. After the video, after the class, go back to the video. Start from the beginning. You understand what I'm teaching you here? I'm not doing magic. 1 minus t raised to the power of 2 dt. It's simple as ABC. Solution. Before we begin to solve this problem, integral, open bracket, 1 minus t raised to the power of 2 dt. I want us to know your elementary algebra. When we have 1 minus t all in square, this is the same thing as 1 minus t times 1 minus t. True or false? So this will going to give us 1 times 1, 1 times minus t times 1 minus t minus times minus plus t times t plus t squared. So you are supposed to have 1 minus 2t plus t squared. Do you understand? So this will now turn to integral, open bracket, 1 minus 2t plus t squared times dt. Right? So this is the same thing as integral 1 dt minus integral 2t dt, then plus integral t squared dt. True or false? Yeah. So this is the same thing. I will factor out 1. So even if you do not write 1, it's the same thing. Integral dt, then minus factor out 2 integral t dt plus integral t squared dt. Right? So far so good. This is the same thing. If you integrate dt, you are supposed to have t. Then minus, if you integrate t dt, you are supposed to have 2 times t raised to the power of 1 plus 1 all over 1 plus 1, right? Then plus, if you integrate t squared dt, you are supposed to have t raised to the power of 2 plus 1 all over 2 plus 1 plus constant c. So the whole thing will now be t minus 2t squared all over 2 plus t raised to the power of 3 all over 3, then plus c. True or false? Look at the board. We'll meet in the class. Any question, you write it down. If you have any question, just write it down. Surely meet in the class. Okay. So let's proceed. Let us proceed to solve more examples. Okay. So let's look at it together. Let's look at another problem together. Here we have integrate 3 all over x squared dx. Okay. So what you need to do, we write solution integral 3 all over x squared dx, right? I want to remind us, assuming we have 3 all over x, this is the same as 1 all over x times 3. True or false? Then, for the fact that the power is 2, we cannot just integrate it like that to give us in x squared. No, it won't work. So it means when we have 3 all over x squared, this is equal to 3 times or 1 all over x squared times 3. Then we apply our indices. We know that if we have something of this one, this is the same thing as x raised to the power of minus 2. True or false? So it means this will now give us 3x squared raised to the power of minus 2. True or false? Look at the board. True or false? It is true, right? Okay, so let's proceed. Let us proceed. So here will now be instead of this, we have to write it in this one, 3x raised to the power of minus 2 dx. Then when we integrate this, we are going to have 3x raised to the power minus 2 plus 1 all over minus 2 plus 1 plus any constant. So this is equal to 3x raised to the power of minus 2 plus 1 is what? Minus 1 all over minus 1 plus a constant. So the answer is minus 3x raised to the power of minus 1 plus a constant. Do you understand? Any question? Do you have any question? Yes or no? Okay, no question. It means we can proceed further to consider more examples. It's all right. Let's look at this idiot here. Integrate 3 square root of x dx. Okay, I want you people to do this one. Let me see your answer first. The first 5 students, I'm going to give you 1 mark. So I give you guys 2 minutes to solve this problem first. 2 minutes. I'm waiting. I'm waiting for you people. I want you to solve it. Amina, he said you are with me spiritually. It's okay. I love that. What is the answer? 1 minute has gone, remaining 1 minute. Nobody. Nobody to solve this question. I is serious. Out of 300 and something students. That is serious. Amina, your answer. Kadifa. Asha Kadifa, your answer. I need your answer. 2x squared x plus c relentless mine 2. I think your answer is wrong. Gospel, almost done. And what is the answer? Gospel, Kadifo. You're writing 2x squared root x plus c. No. It means if people are blind mathematically. Yeah. You guys are blind mathematically. It's okay. Since there is nobody to 2x raised to power 2 all over 2 plus k. It's okay. Let's proceed. Let's look at it together. Solution. Integral 3 root x dx. I want us to know, go back to your indices. Where we have x, square root of x, this is the same as x raised to the power of 1 over 2. True of us, it's true. So here we are going to have integral 3x raised to the power of 1 over 2 dx, because if you cannot transform it in this way, you won't be able to integrate this. So this is the same as factor out 3. 3 is a constant. Integral x raised to the power of 1 over 2 dx. So when you integrate this, you are going to have 3 times x raised to the power of 1 over 2 plus 1, all over 1, all over 2 plus 1, plus any constant. But mind you, when we have 1 all over 2 plus 1 all over 1, this is the same as 2 to 2, 1 times 1, 1, 2 to 1, 2 times plus 1, 2. So we are going to have 3 all over 2, right? So here will now be 3x raised to the power of 3 all over 2, all over 3 all over 2, plus any constant. But let's look at it together. Or we can still rewrite this answer in this form: 3 all over 2 all over, or divide 3 all over 2, then plus a. Then this is the same as 3x raised to the power of 3 all over 2 times 2 all over 3 plus a. This and this will cancel to give us 2x raised to the power of 3 all over 2 plus any constant. So this is the same thing as 2x raised to the power of 3 all over 2 plus any constant. I think somebody was trying to, I think you were somehow close, but you didn't get the answer. We are somehow close. You were somehow close. NS, you are just coming. Sorry about that. So, when you come across questions like that, this is how you are going to look at it. So, let's look at more examples. More examples. Let us look at more examples. Integral minus 5 all over my fourth root of 3 raised to the power 3 dt. It's a very good question. Open your eyes and look at the board very well. Oh, the network is very bad from here. I can see that the network is bad. The network is bad from here. I'm very sorry about it. Network is bad. The network is still bad. Very bad. The network is bad here too. Network is bad. The network is bad. It's okay. Anyway, let's call it a day till Thursday, right? And Saturday. Please, thank you very much. I love you guys. Bye. The network is bad. So let's stop here.